This is a little example that I made up to demonstrate Mathematica's ability to respond to the current mouse location. So we have here a little manipulate output which can display either some points, lines, or rectangles. So what is the point of this? Well, the other thing you can do is magnify them around the current mouse location. So wherever I'm pointing to, we get sort of like a magnifying glass effect where that area of the screen is blown up some. If we have lines, you can see it sort of magnifies the lines, or if we have a grid of rectangles, you can see actually quite clearly what the magnification algorithm is. It's actually sort of Gaussian, I think, maybe not what an actual magnifier would do. And you have some little controls that let you change the magnification ratio, in this case quite extreme, and the radius of the magnifying glass. So how does this work? Well, it's, as is typical in Mathematica, fairly straightforward. If we go back and look at the code, so we have here, this portion is just defining what those three choices of sample graphics are, a list of points, lines, and rectangles. And then we have the manipulate command. The content of the manipulate is a graphics object with a dynamic that allows it to respond dynamically. We use the mouse position function to get the current location of the mouse, and these parameters mean in the coordinate system of the graphic that the mouse is in. So rather than being reported as sort of screen coordinates or something, the mouse position is translated into the native coordinate system of that graphics object. Then we use a function magnify around point, which is defined up here, and it's basically given an arbitrary graphics object and a point, and then a magnification ratio and a radius. And it just sort of applies some rules to this graphics object to tell it, how should a line be magnified, how should a polygon, point, text, all the different kinds of graphics primitives. And it in turn uses this little utility function, which is basically using this sort of distance expanding math to modify the coordinates in the graphics objects. And put that all together, and you get this thing that quite neatly lets you blow up an area of the screen. And you notice that function magnify around point is completely generic. It will do this to any graphics object, not just the sample ones that we've used in this example. So what are some, maybe more serious uses of this? Well, let's take, for example, the graph plot function. This is a very sophisticated automatic graph layout function which produces as its output an ordinary graphics object, which means we can use magnification with it. Let's evaluate this, and we get this sort of network diagram that's been produced very beautifully, but unfortunately there's really too much detail and we can't really see what some of these things are unless we move the mouse over them. And now it's showing us this nicely magnified view, and we can go in and see in great detail what each of these little tails looks like, or what this one is particularly dense here. So this is a way of taking a very large amount of data, providing an overview of it, and also letting you go in and see minute details interactively with the mouse. Another little example here is going to make use of our data packlet functionality. Here we're going to get a list of all of the melting points, boiling points, and densities of the chemical elements. It'll evaluate that, and it's presented them to us here as a sort of a number line where each element is represented by a single tick mark. But there's 118 elements listed here, and there really isn't room to see anything much about each particular one unless you move the mouse over it, in which case we see that it's sort of blowing up that particular area of the plot. In this case it's doing it in a way that's not uniform in the x and y direction. It's using a special version of the magnification function that is designed specifically for this sort of number line display. And then it's also using, it's automatically detecting which line you're over and showing you the name and the particular property for that line, for that element underneath. using basically the same technique as we saw above. The code is slightly more complicated, of course, because it's doing a little bit more here. But this is another example of presenting a large amount of data in a compact area and then providing a dynamic interface to let you see it in more detail.